Hello, it's Mr. Smith. In this video, I will be going through section 2.3 on Venn diagrams and set operations. So let's go ahead and get started. So it says Venn diagrams are used to describe relationships between sets. The four basic relationships between sets are as follows. So first of all, we have what's called disjoint sets, which have no elements in common. So a good example would be if A were the set of dogs and B were the set of cats. You can see that sets A and B would have nothing in common, no elements in common, so those are disjoint sets. All right, let's continue on. Note U is the universal set, the set of all elements under consideration. So for example, in the problem we were just looking at, maybe the universal set is the set of domesticated animals. It's not always clear, but certainly it's either that or perhaps all animals. Okay, so here we have A is a proper subset of B. That's how we read that. That's from before. And you can see that's true because each element in A is also an element in B. And you can also see that A doesn't equal B. Remember, with proper subsets, the two sets cannot be equal. Now, a third relationship between two sets would be when A and B have overlap. So A and B have at least one element in common. So for example, I use this in my classes. If we say A is the set of all students in my class, like in a particular class, and B is a set of people who work, there's normally going to be some overlap. Every class I have has some people that work. And so that's a set or two sets that would have some overlap. And this is our most common relationship when we have two sets. We also have when A is equal to B. So you almost got to get creative on this one. So A equals the clothes I wear to work, and we'll say B is equal to the clothes I wear to church. So they're pretty much the same set of clothes. All right, this set's not all that interesting, or this relationship when they're equal. All right, let's move on. So in number 2, it says identify each described region using the correct Roman numeral. So we have Roman numeral 1, 2, 3, and 4. So we need to identify the region where we're in A and in B. Well, that would be in here. The elements in here would be in A and also B. That's where the overlap is. So that's region 2. In B, not in A. Well, in B means you're in the B circle. If you're not in A, that means you got to discard anything in A, and so that would just be 3. You can do the other two if you'd like, and then turn the video back on. Alright, so not in A or B, so that means you're not in the A circle or the B circle, which means you must be outside of the two circles. That puts us in region 4. And then in A, not in B, so that would be region 1. Alright, so now let's go on to number 3. It says use the Venn diagram to describe each region, and we need to be as specific as possible. So in region 1, we certainly have students, But notice there's something else going on here. This is the parents' circle. And in this region, you're not in the parent circle, so these are students who are not parents. All right, if you want, you can try the other three. I'm going to go ahead and continue here. So in region 2, you have the students who are also parents. So students who are parents. In region 3, you have parents that are not students. They're not in this circle, so they're not students. So parents who are not students. Well, finally, you have region 4, and of course, you're not a student or a parent here, so these are people who are not students or parents. All right, let's go ahead and move on to the next page. Okay, so on number 4 it says children at a birthday party had a choice of cake, ice cream, or both. The results are recorded in the Venn diagram. How many chose ice cream? Well, you've got to be careful here because anybody in this circle chose ice cream. We don't really care whether or not they chose cake. We just want to know how many chose ice cream. That would be 6 plus 8. Or 14. How many chose ice cream or cake? Now, we learned that the definition of or in mathematics and certainly with sets is the idea that it's in one circle or the other or both. So they're in the ice cream circle or the cake circle or both, which means they chose ice cream or cake or both. So we're really just, what I would just use the word combine. We're going to combine these 3 regions. So we have 14 and 10. So 24. How many chose neither? Well, that would be these guys out here. So I don't know who doesn't like ice cream and cake, but I sure wouldn't be out here. I would want both. How many children were at the party? Well, you'd have to add up all these numbers. And so let's do that. We've got 10 plus 6 plus 8 plus 5. And you should get 29 there. All right, so what I would like you to do is now try number 5. Stop the video and then you can check your answers. All right, let's see how you did. So we have students taking English, students taking math. These are the people that are taking both. These are the ones taking neither. So how many were taking English? Well, if you're in the English circle, you're taking English. So 25 plus 12. And what is that, 37? How many were taking English and math? Well, that's the people in here. There's 12 of those. How many were taking math but not English? Well, they're in the math circle, but they're not in the English circle, and so that would be 18. How many students were surveyed? Well, we'd have to add up all these numbers here. So 25 plus 12 plus 18 plus 11. Notice it didn't tell us. And if you add all those up, I'm getting 66. All right. So now on number 6 it says create a Venn diagram to represent the results of the survey. In a survey of 40 musicians, it was found that 20 people played the piano, 25 played the guitar, and 7 played both instruments. So I always tell students with these, you want to work inside out. I always think of that cartoon by Disney. It's one of my favorite cartoon movies. But anyway, that's going to describe our strategy here. We're going to work our way inside out. We'll start in the very middle with the overlap, and then we'll go to these regions, and then finally to the region out here. So let's see, we have 40 musicians. It was found that 20 played the piano. So we have a piano circle. And 25 played the guitar. We have a guitar circle. And 7 played both. And so that's where you want to start. 7 played both. There's 7 that are in both the piano circle and the guitar circle. This is my overlap. So when it says 25 played the guitar, that means there's 25 in the guitar circle. You're going to have to take 25 and subtract the 7 that are already in there, which means there's 18 in here. The common error that people make is they put 25 here, but that would make it more than 25 that are in the guitar circle. So 25 played the guitar. These two numbers should add up to 25. Similarly, we have 20 that played the piano. If there's 7 here, 20 minus 7, there's going to be 13 here. Now keep in mind there were 40 musicians. So let's see if we have anybody out here. We have 13 and 7, which is 20, and another 18, which is 38. And it says they surveyed 40. That means there's 2 out here. All right, let's move on to the next page. And so this is a very similar problem, so I'd like you guys to try that one and then watch the video. All right, let's see how you did. Now, I'm assuming you stopped the video and got your answer. So we have people in the band and people who play sports. Now again, notice there were 320 total students. We're going to need that. 85 in the band, 200 in sports teams, 60 that did both activities. So again, we want to work inside out. We want to start with the 60 here. So if we have 85 in the band and we already have 60 here, then that means there's 25 here. So 85 minus 60 gives you the 25. Notice there are 85 people in the band circle. There's 200 in the sports circle. So we need to take 200 minus the 60 we already have in our sports circle, and that's 140. Again, notice these two numbers add up to 200, and that's how many played sports, so that's how many should be in the sports circle. So finally, we have 320 total students, so we should add these up. We're going to have 225, and we're going to take that from 320, and you should get 95 out here. All right, let's go ahead and move on to set operations. So first of all, the complement of set A symbolized this way. So this is A complement, or we sometimes say A not, or not A, I should say. It's the elements that are not in A, set A. So we'll say not A. Okay, so these are the set of all elements in the universal set that are not in A. So for example, if you have a universal set with 1, 2, 3, 4, 5, and 6 in it. And we say A is 2, 4, and 6, then A complement would be everything in the universal set that's not an A. Well, we already have 2 in A, we have 4 in A, and we have 6 in A. That means 1, 3, and 5 are in the complement of A. The other thing we can do is we can draw a diagram. So we have the universal set, we have the set A in here. So A complement is everything in the universal set that's not an A. That's what the Venn diagram would look like. All right, let's move on to number 2. So the intersection, there's going to be 3 set operations. The second is intersection. The first was complement. So the intersection of sets A and B, symbolized by this symbol here, it looks kind of like a U that's upside down, is the set containing all the elements that are common to both set A and set B. Another way to say them, or say it, is it's a set of elements that are in set A and in set B. I always think about what do the two sets have in common, or what elements do the two sets have in common? So again, I'll give you an example. If A is equal to the set with 1, 3, 5, and 7 in it, and B is equal to the set with 2, 3, 4, 5, and 7 in it, then A intersect B, so that's how we say that. I'm going to go ahead and put this up here. A intersect B, and so A intersect B would be the elements that are in both sets. It's what elements the two sets have in common. Well, they both have 3, and they both have 5 and 7. And so A intersect B would be the set with 3, 5, and 7 in it. Now I'm going to draw a picture. So if you remember back to the beginning of this lesson, we had the case where we have overlap. That's what we have here. A intersect B is this part right here. All right, let's move on. Again, we could put a U out here. All right, the union of sets A and B, which is symbolized A union B. So again, this is A union B, is the set containing all the elements that are members of set A or of set B or both. All right, so for example, if we have A equals the set 1, 3, 5, and B is equal to the set 2, 4, 6, then A union B would include all the elements in A or B or both. So normally what I do is I take everything in A and I add to that everything in B that I don't already have. So in this case, notice we have 1 here, we don't have 2. We have 3 here, we don't have 4. We have 5 here, we don't have 6. So when you're done, you've got all the elements from the first set. Oops, I'm sorry, I just realized I'm off the grid. So you have A is the set with 1, 3, and 5 in it. B is the set with 2, 4, and 6 in it. A union B includes all the numbers from the two sets. I always like to think of the word combine. You're basically combining everything from the two sets. But really what we have is everything in here, or in both. All right, so let's draw a picture of this. So A union B, that's not very good overlap, but we do have overlap here. So it's A, B, and U. So it's everything in A combined with everything in B, and it also includes everything that's in both sets. So it's A, it's in set A, or elements in set A, or B, or both. So all three of these regions. Okay, let's move on to the last page. And let's do some problems. All right, so A intersect B, and by the way, at any point, if you feel like you've got it, I would encourage you to try to do some problems and then watch the video and see if you're doing things right. Try to learn from any mistakes. So A union B will include all the elements that A and B have in common. Well, it looks like they both have G and H. So again, look for the elements that the two sets have in common. Now A union B, we're going to combine everything from the two sets. So for A, we have A, G, and H. Is there anything else we don't already have? Well, in B, there's a B, and we don't have that. So we're going to end up with A, B, G, and H. So if you combine these two sets together, you're going to get A and B and G and H. And that's everything from the two sets. So again, think combine. So A naught is going to be everything that's not in this set, the set A, that's in the universal set. So it can't include A, so it'll then be B. Notice G is the next one, so it'll be B, C, D, E, F. Now notice G and H are in A, and that's the end of the universal set. So these are all the elements in the universal set except for the elements that are in A. So no A, no G, and no H. All right, let's move on to letter D. So you're going to want to first, when you do these types of problems here, you're going to want to take it kind of step by step. We already have A naught, or not A, the complement of A, B, C, D, E, and F. And we're going to intersect that with B complement. Well, we don't have B complement, so I'm going to go ahead and find B complement right here. So that's going to be everything in the universal set that's not in set B. So that's going to be A. And then we have B here, so we won't want to include that. But then it'll be everything from C to F, because once we get to G, we got to stop. So C, D, E, F, and I'm sorry, we need to stop right there. Oops, I'm putting it in the wrong place. We're going to put it in both spots. So A, C, D, E, F, that's B complement. So what are these? So this is A complement, this is B complement. What do these two sets have in common? Well, they have C, D, E, and F. C, D, E, and F. Again, at any point, if you want to try these and then come back and watch the rest of the video, you can see how you're doing. Okay, so here we have A, which is A, G, and H. And we're going to union that with C complement, which we don't have. Well, notice in C, we have B, C, D, E, F, everything from B through F. So in the universal set, we need to take A. not B, C, D, E, or F, and then G and H. So this is actually C complement, and this is A. So what do those two sets have in common? They're the same set. So it's just going to be, I'm sorry, I said that wrong. In this case, we're unioning, or going to do the union of the two sets. So we write the first set, and then nothing new is added because they're the same sets. So you get A, G, and H. Now on F, you're going to want to work in the parentheses first and find A intersects C first. So I'm going to go ahead and find A intersects C. So what do these two sets have in common? Well, they don't have A, they don't have G, and they don't have H in common. And so this is the empty set. So if I want to find the complement of the empty set, well, that's everything in the universal set that's not in the empty set. Wasn't that everything in the universal set? So we could write them all out. We're just going to go ahead and put U here. So the complement of the empty set is the set that includes everything in the universal set. I should say everything in the universal set that's not in the empty set. Well, that's everything in the universal set. All right, let's move on to G. So we have a complement. That's B, C, D, E, F. I'm getting that from problem D. We're going to union that with C complement, which we have here. It's A, G, H. Let's see, what do these two sets have in common? Well, not A, not G, not H. So here, oh, I said that wrong. We're doing the union. I must be getting late. We're going to union these together. So we're going to need A, B, C, D, E, and F, G, and H. Well, isn't that everything in the universal set? So you could write just U, but this is also okay. All right, let's do A union B complement. So first of all, we need to find A union B. So if we combine those two sets together, what do we get? Well, we actually found A union B up here. This was A, B, G, and H. We just combined set A with set B. Now we want the complement of that. So A, B, G, H, complement. So that's what we're looking for here, A union B complement. So it's everything in the universal set that's not in here. Well, we have A and B in here, so we'll have C in the universal set, all the way up to G, not including G. So C, D, E, and F. And we can't have G and H. So our answer is C, D, E, and F. So these are all the elements in the universal set that are not in this set. All right, these last four, you have to kind of think about what we discussed and see if you can reason it out. So you have A, and if you combine that, because this is a union with the empty set, well, the empty set doesn't have any elements. So you're not going to add, when you combine the empty set with A, it's not going to add anything to A. You're just going to get A. On letter J, what do A and the empty set have in common? Well, the empty set has no elements, so these two sets have no elements in common. So here you get the empty set. Here, if you combine set A with the universal set, well, the universal set has all the elements in it. Combining it with A doesn't add anything. You get the universal set. And then finally, if you look for the intersection of A and the universal set, it's what the two sets have in common. it's going to be everything that's in A. And so that would just be A. All right, that's going to be it for this video. If you have any questions, let me know.